Welcome to a journey across the scales of the universe, where gravity is not just a force but a continuous process rooted in the quantum vacuum. Multi-Scale Casimir Gravity, or MSCG, is a framework that connects the tiniest quantum gaps to the grandest cosmic flows. In this video, we'll explore how vacuum energy, structured by boundaries in matter, gives rise to gravity as we know it. From the invisible dance of atomic particles to the swirling flows of galaxies, MSCG offers a unified narrative that bridges quantum physics and cosmology. Let's begin our exploration at the very foundation, the quantum vacuum. At the lowest scale, spacetime is filled with quantum vacuum fluctuations. Even in the absence of matter, every field possesses irreducible zero-point energy. This is not yet gravity, nor even the Casimir effect as we usually think of it. Instead, it's the energetic substrate, the raw spectrum of vacuum modes. Here, there are no forces, only potential. This level supplies the mode reservoir from which all Casimir phenomena and ultimately gravity will emerge. It's a silent sea of energy, waiting for boundaries or matter to give it structure and direction. Moving up, we reach the atomic gap scale. Here, atoms never truly touch. They're separated by persistent quantum gaps. These gaps support modified vacuum modes, leading to Casimir, Polder interactions between neutral atoms. Even inside matter, vacuum-mediated forces operate, creating a distributed negative vacuum energy density. This is the first hint that gravity-like effects can arise from vacuum structure, not just mass. Forces are short-range and average out locally, but the seeds of gravitational behavior are already present in these invisible gaps. We introduce engineered boundaries, like parallel plates or nanostructured gaps. Vacuum modes are deliberately constrained. This leads to the famous Casimir force, a measurable, geometry-dependent pressure that arises even in the absence of charge or mass flow. The Casimir force is strongly scale-dependent, becoming significant at nanometer separations. Here, geometry turns vacuum energy into mechanical force, providing the local stress, energy seed for higher-scale gravitational behavior. This is the microscopic Casimir force regime, the mechanical precursor to gravity in MSCG. At the mesoscopic scale, matter contains vast numbers of microscopic Casimir gaps, interatomic spaces, grain boundaries, and microcavities. When these stresses are summed over volume, they do not cancel perfectly. The result is a bulk vacuum energy density that is material and geometry dependent. This is the handoff region where microscopic Casimir forces begin to coarse-grain, and vacuum response becomes a property of the material itself. Here, the seeds of gravity start to organize into a continuous medium, setting the stage for macroscopic behavior. As we move to larger scales, aggregated vacuum stress reorganizes into a directed vacuum energy flow field, described by a four-vector. This is the macroscopic Casimir gravity regime. Here, gravity is no longer just spacetime curvature, it's curvature plus vacuum flow. The flow direction and magnitude now matter, and the vacuum becomes an active participant in gravitational phenomena. This is where the familiar force of gravity starts to emerge from the underlying quantum structure. In the macroscopic regime, the vacuum flow field becomes a central player. The governing equations now include both spacetime curvature and vacuum energy flow. Matter interacts with this flow through a coupling scalar, and the flow projection scalar determines how time and inertia are experienced. Gravity is no longer a passive background. It's an active, dynamic process shaped by both geometry and vacuum structure. This is the heart of the MSCG framework, unifying quantum and cosmic scales. At the technological scale, human-engineered systems, like metasurfaces and cavity lattices, deliberately sculpt vacuum flow. Here, inertia, weight, and even the rate of time become engineerable quantities. This is the regime where advanced propulsion, weight reduction, and neutral zone formation become possible. The technological scale demonstrates that vacuum energy is not just observable, but can be controlled and used as a physical resource. This is the practical access point to macroscopic Casimir gravity. On the scale of planets and stars, nature aggregates vast numbers of atomic gaps in dense materials, generating macroscopic vacuum flow fields. Here, classical gravity emerges as a low-resolution average of deeper vacuum flow dynamics. Density and composition subtly modify gravitational response, explaining anomalies in extreme environments. The scale shows that natural bodies are large-scale generators of vacuum flow, extending the reach of Casimir gravity to astronomical objects. At the galactic scale, vacuum flow coherence spans entire galaxies, overlapping between stars and planetary systems. Some effects attributed to unseen matter, like flat rotation curves, may arise from structured vacuum flow rather than additional mass. This regime provides a vacuum-based contribution to galactic rotation and large-scale structure, suggesting that dark matter effects could be rooted in the properties of the vacuum itself. At the largest scale, the universe itself acts as a boundary condition on vacuum modes. Global Casimir energy imbalance may contribute to cosmic expansion and time evolution. Here, gravity, time, and cosmology are unified under vacuum flow dynamics, rather than isolated constants. The cosmic scale demonstrates that the structure of the vacuum shapes the evolution of the entire universe. Across all scales, gravity emerges from the way vacuum modes are constrained, aggregated, and allowed to flow. Newton's law is a force approximation, Einstein's relativity is a geometric approximation, and Hartmann's MSCG is the multi-scale completion. There are no discontinuities, just a continuous process from atomic gaps to cosmic flows. Gravity is spacetime curvature plus vacuum energy flow, unified across the universe. Let's revisit the quantum vacuum, the foundation of all Casimir phenomena. Here, the energy is present even in the absence of matter, forming the energetic substrate for everything that follows. This level is essential for understanding how gravity can arise from something deeper than mass or curvature alone. The quantum vacuum is the silent architect of the universe's structure. Atomic gaps are the first physical seat of gravity within the MSCG framework. Here, vacuum structure is embedded inside matter, not just between macroscopic objects. The Casimir-Polder regime shows that gravity-like effects can emerge before classical gravity, purely from vacuum mediation. Heavier elements naturally exhibit stronger vacuum coupling, laying the groundwork for material-dependent gravity. In the microscopic Casimir regime, geometry becomes the key. By imposing boundaries, we can shape, direct, and make mechanical the energy of the vacuum. The Casimir force is a boundary-induced vacuum pressure, scale-sensitive and tunable, but not yet gravity itself. It's the mechanical seed that, when aggregated, leads to macroscopic gravitational behavior. At the mesoscopic scale, vacuum energy becomes a continuous medium. Here, microscopic Casimir forces must be coarse-grained into a field description, and the aggregated vacuum energy forms gradients that lead to directed vacuum flow. This is the interface between the microscopic and macroscopic regimes, where gravity begins to emerge as a spatially organized phenomenon. With the birth of macroscopic flow, gravity is no longer just a force or a curvature, it's a dynamic process involving both. The vacuum flow field interacts with matter, and the flow projection scalar determines how time and inertia are experienced. This regime is the central unifying concept of MSCG, connecting quantum and cosmic scales in a single framework. In the technological regime, vacuum flow becomes a controllable engineering medium. Through advanced structures, we can achieve propulsion without reaction mass, weight reduction, and inertial relief. This is the first practical demonstration that gravity, time, and inertia can be manipulated through the structure of the vacuum itself. Planets and stars, with their immense numbers of atomic gaps and dense materials, naturally generate macroscopic vacuum flow fields. This explains why gravity can vary with density and composition, and why anomalies appear in extreme environments. Nature itself is a grand experiment in Casimir gravity. At the galactic scale, vacuum flow coherence can explain phenomena like flat rotation curves, often attributed to dark matter. The structured vacuum flow fields overlap and interact, providing a new perspective on galactic dynamics and the distribution of gravitational effects across vast distances. On the scale of the universe, the vacuum itself becomes the boundary condition. Global Casimir energy imbalances may drive cosmic expansion and influence the evolution of time and structure. Here, gravity, time, and cosmology are unified under the dynamics of the vacuum, offering a new lens on the universe's fate. The MSCG framework is grounded in precise mathematics. From the Casimir pressure equations at the microscopic scale to the flow field equations at the macroscopic level, each regime is described by clear, stepwise relationships. The crossover between regimes is defined by dimensionless ratios, ensuring a smooth transition from quantum to cosmic scales. Key insight of MSCG is that vacuum coupling depends on material properties, atomic number, density, temperature, and even frequency response. Heavier elements and denser materials couple more strongly to vacuum stress, and frequency-dependent effects can tune the strength and direction of vacuum flows. This adds a rich layer of complexity to gravitational behavior. MSCG encodes two-way permeability between micro and macro scales. Microscopic vacuum stress can source macroscopic flow, while macroscopic flow can modify microscopic mode spectra. This bidirectional exchange ensures that information and energy transfer smoothly across all scales, reinforcing the unity of the framework. The MSCG framework allows for nonlinear self-interaction and anisotropic response in the vacuum flow. Vorticity, twist, and resistance can all emerge from the equations, leading to rich behaviors like bounce, saturation, and directional flow. These effects are essential for understanding complex gravitational phenomena and potential technological applications. MSCG provides a single system of equations that covers Newtonian gravity, Einstein's general relativity, and the Hartmann multi-scale regime. The regime selection is controlled by scale, material response, and the significance of vacuum flow stress energy. This mathematical unity ensures that gravity is described consistently across all physical situations. In MSCG, proper time and inertia become functions of the vacuum flow. The rate at which time passes and the effective inertia of matter can be modulated by the flow projection scalar. This opens the door to new phenomenology, where clocks and masses respond to engineered or natural vacuum flows, with potential applications in advanced technology and fundamental physics. The MSCG poster visually summarizes the journey from quantum gaps to cosmic flows. Each panel corresponds to a physical regime, with clear transitions and mathematical relationships. The visual narrative reinforces the idea that gravity is a continuous, scale-bridging process, rooted in the structure and dynamics of the vacuum. Summarize, Multi-Scale Casimir Gravity treats microscopic Casimir vacuum stress as the seed for macroscopic vacuum flow fields. Matter couples to this flow, and the crossover between regimes is governed by clear mathematical criteria. Newton and Einstein appear as limiting cases, while the Hartmann regime completes the picture with a unified, scale-bridging approach. Multi-Scale Casimir Gravity reveals that gravity is not a single-scale phenomenon, but a continuous process evolving from quantum gaps to cosmic flows. The vacuum is the missing connective medium, completing the story of gravity from the smallest particles to the largest structures in the universe. Thank you for joining this exploration of the deep structure of reality.